Welcome back, my dear students, to the second part of the chapter electrolysis. Here, as I have told you in the previous video, that I will be teaching you examples of electrolysis. The first example of electrolysis is called electrolysis of molten lead bromide. This I am going to explain you with the help of a diagram again. Okay, let me explain you the first application, use of electrolysis, which is called electrolysis of molten lead bromide. Here, if you look at the diagram, there is a container. There is a container which is made of silica crucible. In this container, we have taken molten lead bromide, PbBr2. The temperature to keep this lead bromide in the molten state, it is approximately 380 degrees Celsius. The anode is made of graphite. This is the anode. The cathode is made of iron or graphite. The anode carries positive charge. The cathode carries negative charge. Now, what are the ions present in this molten lead bromide? Let us see that. Ions present. Lead bromide, it is an electrovalent ionic compound. So, in the molten state, it dissociates to produce lead ions and bromide ions. So, these are the two types of ions present in this electrolyte, which is molten lead bromide. Now, let me write these two ions in this diagram. Pb plus 2 and twice Br minus 1. In the beginning, the switch is off. When the switch is put on, electrons flow this way, current flows this way. The anode acquires a positive charge, the cathode acquires a negative charge, because of which the cation, which is lead ion, goes to the cathode and the anion, bromide ion, goes to the anode. Now, this is how the separation of ions takes place. Now, at cathode, the lead ion goes to the cathode, Pb plus 2, it goes to the cathode over there, and it takes 2 electrons and forms lead metal. It takes 2 electrons. Each lead ion takes up 2 electrons and it forms neutral lead metal atom and deposits on the iron or graphite cathode. When lead has deposited on the iron or graphite cathode, we can see it is a silvery deposit, silvery grey deposit. On the other side, at the anode side, 2 bromide ions come to the anode. 2 bromide ions, they come to the anode over here. They lose altogether 2 electrons and form 2 bromine atoms. form two bromine atoms. These two bromine atoms, they combine to give bromine gas. The color of this bromine gas is reddish brown. It is a reddish brown gas, like nitrogen dioxide gas. So, this is how the electrolysis of molten lead bromide takes place. Let me revise once more quickly. In the electrolysis of molten lead bromide PbBr2, the container, the vessel, the electrolytic cell, it is made of silica crucible. Why do we use silica crucible? Because silica crucible can withstand a very high temperature. Then, inside the silica crucible, in the beginning, solid lead bromide is placed. And then it is heated by using a Bunsen burner up to a temperature of 380 degrees Celsius. When this solid lead bromide, it melts and it becomes molten lead bromide. The flame must be kept on to keep this lead bromide in the molten state. The temperature is maintained at 380 degrees Celsius. And now when the switch is put on, the lead ions go to the cathode. They discharge over there by taking up two electrons to form lead metal, which is a silvery grey deposit. The two bromide ions go to the anode. Two bromide ions, they will lose altogether two electrons to form two bromine atoms, which recombine to form bromine gas, which is reddish brown colored gas. In this electrolysis of molten lead bromide, the current which is passed through this molten lead bromide, it is 3 amperes. It is 3 amperes. It is 3 amperes. So, what are the questions which can be asked from this electrolysis of molten lead bromide? Let us see. They will ask, what are the ions present? So, if they ask what are the ions present, then you must be able to write down this equation. PbBr2 producing lead ion and two bromide ions. The next question they can ask is, what is the reaction taking place at the anode? This is the reaction taking place at the anode, this part. At the anode, two bromide ions lose two electrons to form two bromine atoms, which recombine to form bromine gas, which is reddish brown in color. At the cathode, the lead ion, it goes to the cathode, it takes up two electrons and it forms lead atom and deposits on the cathode. The color of lead atoms after deposit, it gives it a silvery grey color. This is electrolysis of molten lead bromide. Now let me explain you the second example of electrolysis. Okay, here we have the diagram for the second example of electrolysis, which is called electrolysis of acidified water. In this electrolysis, we take a container. And this container is filled with water. It is filled with water, and this water is acidified. This water is acidified with dilute sulfuric acid. Now, let me explain you over here why water is treated with dilute sulfuric acid. Pure water, it's a bad conductor of electricity. Therefore, we put few drops of dilute sulfuric acid in this water to increase its conductivity. Another important thing, the electrolysis of acidified water is an example of catalysis, because here we are using dilute sulfuric acid to increase the conductivity of this water, which is again regained back once the electrolysis is complete. Now, the next part, let me explain. There are two test tubes over here. There are two test tubes upside down put in this water, but these test tubes are filled with the same acidified water. They are completely full till the brim over here. Now, just these test tubes are clamped with the help of side stands at the side so that they don't fall off. Now just at the mouth of the test tubes we keep platinum foil, metal platinum. Now this metal platinum, it is an inert electrode. I have discussed this in the third factor affecting selective discharge of ions. Platinum is an inert electrode which does not participate in the electrochemical reaction. It simply helps in the conduction of current only. Now these are two platinum foils. This platinum foil, it is connected with the help of connecting wires to the switch and to the positive terminal of the battery. So this platinum foil becomes the electrode which is called anode, carrying positive charge. This platinum foil, it is connected by means of wires and it is connected to the negative terminal of the battery and it is called cathode. And this cathode carries negative charge. So now this is the diagram for the electrolysis of acidified water. Now let us see what are the ions present. Now in this electrolysis of acidified water, water is the main component. So water is going to provide us with H plus and OH minus ions over here. The other component is dilute sulfuric acid. Please keep in mind, dilute sulfuric acid is added only up to 4 to 5 drops only, just to increase the conductivity of this water. So dilute sulfuric acid H2SO4, it is going to provide me with hydrogen ions and sulfate ions, SO4 minus 2 ions. So these are the ions which will be present in this electrolytic solution. The electrolyte over here is acidified water. So let me write these ions in this diagram over here. So there is hydrogen ion, H plus ion. The next ion is OH minus ion. The next ion is sulfate ion, SO4 minus 2 ion. Now the switch is off. In the beginning. Now when the switch is put on, electron flow, current flows, and then now the cation, there is only one cation over here, that is hydrogen ion. The cation goes to the cathode. And the anions, hydroxyl and sulfate, they go to the anode. Please keep in mind, cations go to the cathode, cations carry positive charge, so they go to the negative electrode, and anions carry negative charge, so they go to the positive electrode. This is very, very important to remember. Now at cathode, let us see what happens. At cathode, hydrogen ion, H plus ion, one hydrogen ion, it takes up one electron to become hydrogen atom. So that is how hydrogen ion discharges at the cathode, by taking one electron. Gain of electrons, I have told you, it is reduction. I hope you remember red cat. Gain of electrons is called reduction. Now let us come to the anode side. At anode, the hydroxyl and the sulfate ion, they come to the anode. But between hydroxyl and sulfate, which one will discharge? The ion which is placed lower in the electrochemical series will discharge. So between hydroxyl and sulfate, which is lower? Hydroxyl. So hydroxyl is going to discharge. So whenever hydroxyl ion discharges, always keep in mind, we must take 4 hydroxyl ions. So here at the anode, 4 hydroxyl ions will lose total 4 electrons and produces 2 water molecules and one oxygen molecule. This is one oxygen molecule. Now, have a look very carefully over here. I repeat once more. Whenever hydroxyl ion discharges, we must take 4 hydroxyl ion losing 4 electrons to produce 2 water molecules and 1 oxygen gas molecule. So, at the anode, since I have taken 4 hydroxyl ion losing 4 electrons, therefore at the cathode also what I must do, I must take 4 hydrogen ions gaining altogether 4 electrons to form 4 hydrogen atoms, 4 of them. Now these 4 hydrogen atoms, they rearrange to produce 2 hydrogen gas molecules. 2. This is 2. 2 over here. So this is electrolysis of acidified water. So what is happening now? At the anode, oxygen gas is formed. So the oxygen gas bubbles up. It bubbles up, it goes up over here and pushes the water down and collects over here. At the cathode side, 2 hydrogen gas molecules are formed. So hydrogen gas is formed over here at the cathode. It goes up and pushes the water down, displaces the water down, and the hydrogen gas collects over here. Now, when sufficient electrolysis of acidified water has been carried out for quite some time, we will notice that the volume of oxygen gas formed is 1 volume. This is 1 volume over here, 1 volume. And the volume of over here hydrogen gas formed is 2 volume. 2 volume. Now this sulphate remains over there. It combines with any other undischarged hydrogen ions to give back sulfuric acid. That is why we say electrolysis of acidified water is also an example of catalysis. So, what are the questions which can be asked from here? Please try to keep the diagram in your mind. Not for the sake of drawing, but they will ask questions based on the diagram. The diagram will be given to you and there will be questions asked on the diagram. So, they will tell you, they will ask you what is the charge of the anode, what is the charge of the cathode. Write down the ions present. So, this is how you must write down the ions present. H plus, OH minus, 2H plus and SO4 minus 2. They will ask you, write down the reaction at the anode. So, you have to write this way, 4 hydroxyl ions losing 4 electrons to form 2 water molecules and 1 oxygen gas molecule. And they will ask you, what is the reaction at the cathode? So, you have to write down 4 hydrogen ions gaining 4 electrons to form 4 hydrogen atoms, which rearrange to form 2 hydrogen gas molecules. And never forget to remember that at anode there is loss of electrons. There is loss of electrons means it is what? It is oxidation. At the anode it is always oxidation. And at the cathode there is gain of electrons, so it is always reduction. It is always reduction. This is already easy for you because I have told you red cat, cathode reduction. And at the anode it is oxidation. How will you remember? Anox. Anox. So I have explained you now the second example of electrolysis, which is called electrolysis of acidified water. Now I will explain you the third example of electrolysis. Okay, let me explain you the third example of electrolysis, which is called electrolysis of aqueous copper sulphate solution using platinum electrodes. First, let us understand the diagram. There is a container. And in this container, we have placed aqueous copper sulphate solution. And this aqueous copper sulphate solution is acidified with dilute sulfuric acid. Why dilute sulfuric acid? To increase the conductivity of the solution. Then, the anode and the cathode, they are made of platinum. And platinum is an inert electrode. It is an inert electrode. Platinum is an inert electrode. Remember that. The anode carries positive charge, the cathode carries negative charge. Clear till here? Now, let us see what are the ions present. Ions present. Ions present. Since it is aqueous copper sulfate solution, aqueous means there is water, so I must write water, H2O. So water ionizes to give H plus and OH minus ions. Then there is copper sulfate. Copper sulfate dissociates to give copper ions and sulfate ions. And then I have added few drops of dilute sulfuric acid. So sulfuric acid dissociates to give hydrogen and again sulfate ions. So these are the ions present in this electrolytic solution. Hydrogen ion, hydroxyl ion, copper ion and sulfate ion. Now I am going to write these ions one each in this diagram. So the first ion I will write is H plus. Then we have OH minus. Then we have Cu plus 2. Then we have SO4 minus 2. SO4 minus 2. So these are the ions present in this electrolyte, which is aqueous copper sulfate solution acidified with dilute sulfuric acid. Now, please keep in mind, aqueous copper sulfate solution, before carrying out the process of electrolysis, this aqueous copper sulfate solution is a blue, it's a blue transparent solution. Blue transparent solution. It is a blue color transparent solution, like the color of this. Okay, it is a blue transparent colored solution. Now when I put on the switch, electrons move this way, current starts to flow, and then now there is movement of ions to the respective electrodes. Now the cations, that is hydrogen and copper. The cations, which are hydrogen and copper, they go to the cathode. Now, amongst hydrogen and copper, which one will discharge? Which is placed lower in the electrochemical series? Think, it is copper. So, amongst hydrogen and copper, since copper is placed lower in the electrochemical series, it is copper which will discharge. So, at cathode, what happens? Copper ion, Cu plus 2 ion, it will take up 2 electrons and it forms copper atom and deposits on the cathode, which is made of platinum. Okay, so here there is gain of 2 electrons. Hydrogen does not discharge. Why? Because it is placed above copper. Now come to the other side. Now the anions, hydroxyl and sulfate, they come to the anode like this, because the anode is carrying positive charge. So this anode is going to attract the anions, hydroxyl and sulfate. Now amongst hydroxyl and sulfate, which one is placed lower? It is hydroxyl. So hydroxyl will discharge, sulfate will not discharge. So at the anode, it is hydroxyl. Since I have told you already in the previous example, whenever there is discharge of hydroxyl ions, remember number 4. So 4 hydroxyl ions discharge at the anode by losing 4 electrons to produce 2 water molecules and oxygen gas molecule. And the sulfate does not discharge. It remains at the bottom over here, and then it combines with unreacted, undischarged hydrogen ions to form sulfuric acid, which is acting as a catalyst, we can say. Now here, as time goes by, slowly and steadily, all the copper ions which are present in this electrolytic solution, they are getting discharged at the cathode. So the concentration of copper ions is decreasing. So a time comes when the color of this, the blue color of this aqueous copper sulfate solution, it fades away, it goes away. So the solution turns it fades away. It fades away. We can say the solution turns colorless also because the concentration of copper ions has decreased. The loss of copper ions at the cathode is not compensated by the anode. That is why the color fades away. So now this is electrolysis of aqueous copper sulphate using platinum electrodes. So you must remember the diagram, not for the sake of drawing, but for the sake of answering questions based on the diagram. So in this diagram there is a vessel. In this vessel we have taken aqueous copper sulphate solution acidified with dilute sulfuric acid. The anode and the cathode are made of platinum, which is inert electrode, which does not participate in the electrochemical reaction. The cations move to the cathode, anions move to the anode. Amongst the cations, copper discharges by gaining 2 electrons to form copper atom. At the anode, between hydroxyl and sulfate, hydroxyl ions discharge by losing 4 electrons to form water molecule and oxygen molecule. Now here at the anode there is loss of 4 electrons. Here also there must be loss of 4 electrons. So what we can do is, we can catch hold of one more copper ion to gain 2 more electrons to form another copper atom. So the total number of electrons which are gained at the cathode, the total number of electrons which are gained by the ions at the cathode must be equal to the total number of electrons which are lost at the anode. Then only the electrolysis is correct, theoretically. So again, what are the questions which can be asked from here? You must remember the diagram and then ions present. From the heading over here, aqueous, so water, copper sulphate, so copper sulphate, break this equation, write the ions, and then there is sulfuric acid, so break sulfuric acid, dissociate to give hydrogen and sulfate, and then write these ions over here, put on the switch, and then you can calculate yourself which ions will move in which direction, and then accordingly you must be able to write down the reaction at anode in this manner and the reaction at cathode in this manner. Now I will explain you the next example of electrolysis which is similar to this, and it will be called electrolysis of aqueous copper sulphate solution using copper electrodes, which is also an example of electrorefining of copper. Okay, now we have the next example for electrolysis. You can see the diagram on the board. This is the diagram for electrolysis of aqueous copper sulphate solution using copper electrodes. In the previous one it was platinum electrodes, but here it is copper electrodes. The electrodes are made of copper. Now let me explain you in detail. Now again there is a container. The electrolyte is aqueous copper sulphate solution containing few drops of dilute sulfuric acid to increase the conductivity. Now the anode, it is made of thick impure copper block. The anode is made of thick impure copper block, because this electrolysis is also an example of electrorefining of copper metal. So that's why the anode is made up of thick impure copper block. The cathode is made up of thin pure copper strip, like this. Now like the previous example, again the ions present, I will not write the ions present. The ions present are H plus, OH minus, Cu plus 2, copper ion, SO4 minus 2, etc. So these are the ions present in this aqueous copper sulphate solution. Now the color of aqueous copper sulphate solution is, again, it is light blue, LIGH, light blue colorless solution, transparent solution. Light blue transparent solution. You can see through the solution. It is light blue in color. Now when the switch is put on, the electrons move this way, current starts to flow, and then the ions, that is the cations, hydrogen and the copper, move towards the cathode, to the cathode that side, which is a thin pure copper strip. Between hydrogen and copper, since copper is lower in the electrochemical series, so at cathode it is the copper ion which will discharge. So what happens? Cu plus 2 will take up 2 electrons and it forms copper atom. Copper atom. So that is the reaction happening at the cathode. That is very easy. Okay. Now come to the anode side. At the anode side, the hydroxyl and the sulphate ion, they come very happily to the anode, but none of them will discharge. None of them will discharge. The reason is that here the anode is made of copper and copper electrodes are active. Copper electrodes are what? They are active. They participate in the electrochemical reaction. That is why this anode, which is made of an active electrode, will prevent, it will not allow the hydroxyl or the sulphate to discharge. So what happens over here? It is the anode which is made of copper. At the anode, the copper atom which is there on the anode, it will lose 2 electrons. It will lose 2 electrons, give away 2 electrons, and it will enter the solution. It will enter the solution by forming copper ions. The electrons complete the circuit. So at the anode, what is happening? The anode, which is an active electrode made of copper, it prevents these ions from discharging. And then this copper atom on the anode, it loses 2 electrons and it forms copper ions and enters the solution. So this is slightly different from the previous example. Here, this electrolysis of aqueous copper sulphate is also an example of electrorefining of copper. By using this method, we can easily electrorefine copper metal from an impure copper block. Now, what happens after that? The hydroxyl ions and the sulphate ion, they remain at the bottom over here. All the impurities collect at the bottom, and the impurities which collect at the bottom of the anode, they are named as anode mud. Anode mud. Another thing you must remember over here is, in this electrolysis of aqueous copper sulphate solution using copper electrodes, the blue color, the light blue color of this solution does not fade away. It does not disappear. Why? In the previous one I told you that the light blue color disappears because copper ions, concentration of copper ions were getting lowered. But here, for the loss of every copper ion at the cathode, a copper ion is generated at the anode. So as long as there are copper ions in the electrolyte, the color of the electrolyte will be light blue in color. So this is my example for the electrolysis of aqueous copper sulphate using copper electrodes. Now the examples are complete. Now I'll be explaining you very quickly the applications of electrolysis. Okay, now let me explain you the first example of the application of electrolysis. Now the first one, it is called nickel plating. The plating of an article, the plating of a baser metal by a superior metal, it is called electroplating. So here a base metal can be iron, and the superior metal is nickel. So in this nickel plating of an article with nickel, it is called nickel plating. Here the electrolyte is aqueous nickel sulphate solution acidified with dilute sulfuric acid. I am using dilute sulfuric acid all the time because dilute sulfuric acid helps to increase the conductivity of the electrolytic mixture. The anode now carrying the positive charge, here in this case it is made of nickel block, and the article to be electroplated, it is made the cathode. I have taken an iron nail, a nail made of iron. Electroplating helps to prevent rusting or corrosion. It makes the article look attractive. Okay, these are the advantages. Now the iron nail, it is the article to be electroplated by the nickel metal. So let us see what are the ions present. Ions present. It is aqueous, so definitely water will be there. Water produces H plus and OH minus ions. Nickel sulfate. So nickel sulfate will produce nickel ion and sulphate ion, and there is dilute sulfuric acid. Dilute sulfuric acid will produce H plus and SO4 minus 2 ions. So these are the ions present in this electrolytic mixture. So let me write them down over here. H plus, OH minus, Ni plus 2 and SO4 minus 2. Now when the switch is put on, electrons flow, current flows. The cations, that is hydrogen and nickel, they go to the cathode. The anions, that is hydroxyl and sulfate, they come to the anode. Now first at the cathode, what happens at the cathode? At cathode, between hydrogen and nickel, let me tell you, between hydrogen and nickel, the position of nickel is supposed to be lower than the position of hydrogen. You will not find the position of nickel in the electrochemical series in your class 10 textbooks. But here it is a special case. Please remember, the position of nickel is lower than that of hydrogen. That is why at the cathode, instead of hydrogen, it is nickel which discharges. So nickel ion, it gains 2 electrons and it forms nickel atom and deposits on the iron nail. It deposits on the iron nail. And then on the other side, between hydroxyl and sulfate, both of them come to the nickel anode block, but none of them will discharge. The reason is the nickel block, it is an active electrode. As I have told you, like copper, nickel is an active electrode. So this nickel metal will prevent the discharge of hydroxyl and sulfate ions. So what will happen? A nickel atom on the block at anode, a nickel atom on the block will lose 2 electrons and it forms nickel ions, and then it enters the electrolytic mixture. So here we have seen at the anode, nickel atom is losing 2 electrons and forming ions and entering the solution. And from the solution, nickel ions are going to the cathode, which is made of iron nail, and discharging over there and depositing on the iron nail. So when we carry out this electrolytic process for quite some time, all the nickel atoms from the anode, they get transferred to the cathode, and a very nice firm even deposition of nickel takes place on the iron nail. The iron nail appears as if it is made of nickel, and this is the advantage over here. Iron nails coated with nickel, they do not get rusted. Rusting is prevented. Okay, so this is called nickel plating. The questions are here only like the previous cases. The diagram, what is the article at the cathode? It is to be electroplated. The metal to be electroplated is made the anode. A low current should be passed for a longer time. That is very, very important. A low current should be passed for a longer time. Okay. And then the type of current which should be used is always a direct current. As I have told you the very first thing in this chapter, that for electrolysis to be carried out properly, nicely and correctly, we must always use a DC current, direct current. We cannot use an alternating current. So now I have explained you the first example of the application of electrolysis. I will explain you next the last example of electrolysis, which is called silver plating. Okay. Okay, now we have the next example of the application of electrolysis, which is called silver plating. Electroplating of an article with silver. Okay, now look at the diagram. There is a container. In this container we have placed aqueous sodium argentocyanide, sodium silver cyanide. It is the electrolyte. It is this compound sodium silver cyanide is dissolved in water and a solution is made. Okay, the anode, it is made of a pure silver block. It is a pure silver block. The cathode, which is negative charge, it is an iron spoon. This is the article to be electroplated. Now, the ions present are from water H plus and OH minus, from sodium argentocyanide it is Na plus, Ag plus and 2Cn minus. So these are the ions present in this electrolytic mixture. So let me write them down. H plus, OH minus, Na plus, Ag plus and Cn minus. Now, when we put on the switch, the electrons flow this way, current flows this way, and then the cations H plus, Na plus and Ag plus, they go to the cathode. There are 3 cations going to the cathode. And at the anode, the hydroxyl and the cyanide come to the anode. Now, what happens at the cathode? Let us see. Amongst hydrogen, sodium and silver, if you look at the electrochemical series, we will find that the position of silver is at the bottom. So, at cathode, it is silver ion which discharges. So, silver ion Ag plus 1, it will gain 1 electron and it forms silver metal and deposit on the silver, this iron spoon over here, form a coating over there. Whereas at the anode side, the hydroxyl and cyanide come to the anode, but none of them will discharge. The reason is silver, it is an active electrode. Silver electrode is an active electrode. It will prevent the discharge of these 2 ions. Okay, so therefore, what happens at the anode? At anode, the silver atom on this block, it will lose 1 electron and it forms silver ions and then enters into the solution. So, when this is carried out for quite some time, when you pass a low current for a longer time, slowly and steadily, all the silver atoms, they lose electrons and enter into the solution by forming ions, and then they migrate to the cathode and then they gain electrons and form silver atoms by depositing on the iron spoon. So, when this is carried out for quite some time, the iron spoon gets a very firm, thin and an even deposit of silver on it. It appears as if it is a silver spoon. So this is how we carry out or understand, which is called silver plating. Now, what are the questions they will ask you? Direct questions over here. Reaction at anode, reaction at cathode. What is the nature of the anode, active electrode? Why is sodium argentocyanide used? Why don't they use any other electrolyte like silver nitrate? Why don't we use silver nitrate? They can ask this also. We don't use silver nitrate as the electrolyte instead of sodium argentocyanide because silver nitrate, it is a strong electrolyte. It is a very strong electrolyte. So what will happen? If I use silver nitrate, then the electrolytic process becomes very fast. It becomes so fast that there will be uneven deposition of silver on this iron spoon. That means some parts of the spoon will have more silver, some parts of the spoon will have less silver, some parts of the spoon will have no silver at all. So that is not required by us. We want an even deposition of silver on the spoon. That is why we don't use silver nitrate as the electrolyte over here during the process of silver plating. So this is my second example for the application of electrolysis. Now, the main things I have already explained you. Please go through my lesson from the school's website, which will be uploaded very shortly, like conditions for electroplating, what are the advantages of electroplating, and as I have told you, please learn at least few examples of strong electrolytes, few examples of weak electrolytes, few examples of non-electrolytes. Learn the comparison from the textbook between electrolytic dissociation and ionization. Learn the comparison between metallic conduction and electrolytic conduction from my notes. Okay, and this brings us to the end of this video. Have a nice day. Thank you.